Hello, monkeys. Imagine looking up at the night sky, seeing countless stars and galaxies stretching into infinity. Now, what if I told you that everything we see, every star, planet, and even the tiniest speck of dust, makes up only 5% of the universe? The rest? It's completely invisible to us. We can't see it, we can't touch it, but we know it's there because of the way it shapes the cosmos. Scientists call these hidden forces dark matter and dark energy, and they are some of the biggest mysteries in physics today. Dark matter seems to hold galaxies together, acting like an invisible glue, while dark energy is pushing the universe apart, making space expand faster and faster. We don't fully understand either of them, but what we do know has already changed the way we see the universe. So today, let's explore the invisible side of the cosmos, what we know, what we don't, and the mind-blowing possibilities of what could be out there. Dark matter is one of the most mysterious substances in the universe. We can't see it, touch it, or detect it directly, yet it makes up about 27% of the cosmos. So, how do we know it even exists? The answer lies in how galaxies behave. If we only consider the visible matter, stars, planets, and gas clouds, their gravity alone isn't strong enough to keep galaxies together. Based on the laws of physics, galaxies should be spinning apart, with stars at the edges flying off into space. But they don't. Instead, they stay in place, orbiting around the galactic center as if some unseen force is holding them together. That force? It's what scientists call dark matter, an invisible substance that adds extra gravity, acting like cosmic glue. How do we know dark matter exists? If we can't see dark matter, how do we even know it's real? Scientists have a clever trick to detect its presence, something called gravitational lensing. It's when light from distant galaxies bends around an invisible mass, like a cosmic magnifying glass. This bending tells us that something unseen is affecting the light's path. That something is dark matter. Here's a simple way to picture it. Think of a glass of water. When you put a straw inside, it looks bent or shifted because water bends light as it moves from air into the liquid. Now, imagine space itself works like that, except the bending happens because of an invisible force, dark matter. Astronomers use powerful telescopes to spot these light distortions in space. They map where light bends the most and find huge halos of unseen matter surrounding galaxies. What could dark matter be made of? Scientists have a few big ideas, but no one knows for sure. One possibility is WIMPs, weakly interacting massive particles. These are hypothetical particles that barely interact with normal matter, making them incredibly hard to detect. Then there are axions, tiny particles that could behave strangely under certain conditions. Some researchers even think dark matter might be something totally unknown, a new fundamental force of nature we haven't discovered yet. Right now, scientists are hunting for dark matter deep underground, using massive detectors shielded from cosmic radiation. They're also smashing particles together in powerful colliders, hoping to create or detect traces of these mysterious particles. And here's a wild idea: what if dark matter is linked to parallel universes? Some physicists speculate that dark matter could be regular matter in another dimension, only interacting with our universe through gravity. What is dark energy? If dark matter pulls things together, dark energy does the opposite, it pushes things apart. For a long time, scientists thought the universe's expansion was slowing down due to gravity. But in the late 1990s, astronomers made a shocking discovery: the universe isn't just expanding, it's expanding faster and faster. Something is fueling this acceleration, and we call it dark energy. And here's the mind-blowing part: dark energy makes up about 70% of the entire universe. It's literally the dominant force shaping our cosmos, yet we have almost no idea what it actually is. How do we detect dark energy? Since we can't see dark energy, how did we discover it? The answer came from studying supernovae, massive exploding stars. Astronomers were measuring the distances of these explosions and expected to see galaxies slowing down due to gravity. Instead, they found the opposite. The galaxies were accelerating away, as if some unknown force was pushing them apart. That unexpected force? Dark energy. Theories about dark energy. Scientists have a few leading ideas about what dark energy could be. Vacuum energy. This idea suggests that space itself has energy, constantly pushing outward like an invisible force field. This comes from quantum physics, where even empty space isn't truly empty, it's buzzing with virtual particles that could create this mysterious energy. New physics. Some scientists believe our current understanding of gravity isn't complete. There might be a missing law of physics that explains why the universe is accelerating. If this is true, discovering dark energy could completely rewrite what we know about the cosmos. Right now, dark energy is one of the biggest mysteries in science. The more we study it, the more we realize that the universe is far stranger than we ever imagined. Could solving this mystery lead to new physics? New discoveries about space-time? Maybe even a deeper understanding of the multiverse? One thing's for sure, the search is far from over. If you loved this video, hit the like button, subscribe to Monkey in Space, and let's keep exploring the wonders of the universe together. What do you think dark matter and dark energy could be? Let me know in the comments.